Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Atika binti Muhammad Nazi. For my FYP2 is a review report. My title is Antimicrobial and Antioxidant Activity of the Eleutherine bulbosa, Bawang Dayak review. On my research background, Eleutherine bulbosa bar, also known as a Bawang Dayak, Bawang Hutan or Bawang TY, is a hibiscus perennial blooming plant from the Iridaceae family that is widely grown in South America, Africa and Indonesia. Eleutherine americana, Eleutherine palmifolia, and Eleutherine platifolia are some of the scientific names that are used interchangeably depending on the local. The Bawang Dayak bar was thought to offer qualities that might help with the breast cancer, hypertension, diabetes, cholesterol, and so on. The Eleutherine bulbosa contain bioactive chemicals such as naphthalene, nitroquinone, and anthraquinone, which have been shown to have antimicrobial, anti-inflammatory, antibiotic, and viral replication inhibitor activities. For the progress statement, in many regions of the world, there are numerous traditional herbal preparations for the treatment of infectious disease. Despite tremendous progress in human medicine, communicable disease remains a major public health problem. The E. bulbosa in the antimicrobial and antioxidant potential has been poorly studied by the modern laboratory method. For my objective is to analyze the antimicrobial activity of the E. bulbosa in antibacterial and antifungal properties. Second is to investigate the antioxidant activity of the E. bulbosa. Significance of the study. Natural products are a great choice for alternative medicine in the treatment of the sickness. E. bulbosa has a range of the medical possibility. Antimicrobial susceptibility testing can be used for the drug development, epidemiology, and treatment outcome prediction. Microbial and plant products account for the vast majority of the antibacterial chemical identified of date. Eleutherine is a hibiscus rhizomatous and a perennial blooming plant with a primary red and white bulb, hue similar to the red onion, growing to a height of 20 to 30 cm. They have plenty entire leaves that are 25 cm long on the average, with a huge panicle on the white or pink flower position at the top of a tall, thin scale above of the foliage. Microscopic analysis of the E. bulbosa bud reveal variable size on the parenchymal cell and distinct form of the calcium oxalate crystal, primarily a styloid structure. This figure shows the morphology characteristic of the E. bulbosa. The figure A is a rhizomatous large red bulb that resembles a red onion, and B is a planted linear lanceolate leaf. Antimicrobial activity of E. bulbosa. Antibiotic is a collection term for all active principles that inhibit the growth of the bacteria, prevent the formation of the microbial colonies, and may destroy microorganisms. The minimum inhibitory concentration (MIC) is used to assess susceptibility and resistance of bacteria. E. bulbosa is an effective antimicrobial agent due to its high concentration of bioactive chemical in the phytochemical elements. The antibacterial properties of the E. bulbosa can increase in immune response and resistance to the viral parahemolyticus infection in white shrimp for the 30 days of extraction. The E. bulbosa ethanolic bulb extract greatly inhibited the development of the Brevi Haveyi in a dose-dependent manner. The water extract of the E. palmifolia bulb inhibited the growth of the E. coli with an inhibited diameter of the CMN at the lowest concentration of the 10% and 100% when compared to the positive control. Next, the antifungal properties when the fungal infection are a global concern to human health, causing the estimated billion skin and mucosal infection, allergy, and death each year. Natural resources include a variety of the bioactive chemicals, including penicillin, which was the first antibiotic to develop. The essential oil produced from the E. bulbosa bulb was also effective against malassezia fever, a fungal infection of the skin structure corneum that can lead to the pityriasis vasculorum. The antioxidant activity of the E. bulbosa. The antioxidant are powerful free radical scavenger that may help to mitigate the oxidative damage caused by chronic and degenerative illness. Phenol and flavonoid may protect the fatty acid from the oxidative destruction. Because of the growing need for the natural antioxidant and fruit preservative, the antioxidant capability of the medical plant have received more study. The terpenoid and the flavonoid content of the E. bulbosa bulb, leaf, and the flower was determined by using parasite scavenging capacity (PSC) test. The higher of the flavonoid or total phenol concentration, the greater the antioxidant potential. Based on the previous research, this study identifies some gap in the antimicrobial activity of E. bulbosa. The antiviral activity of the E. bulbosa are one of the smaller gap in the antibacterial activity. Because the isoeleutherine and isoleutherol reduce HIV replication, Bawang Dayak SEV antiviral potential. Bioactive nitroquinone derivative found in Bawang Dayak are commonly employed as antiviral, antibacterial, antifungal, and antiparasite medicine. Furthermore, the result of all research conduct do not show E. bulbosa antibiofilm capacity. Many studies of the E. bulbosa as an antibiotic and anti-cancer agent have been undertaken. However, research on the E. bulbosa as a anti-biofilm agent is still fairly limited. Biofilm production causes several issues in pharmaceutical, healthcare, and the food industry, among others. Finally, there are still lack of the study of the mechanism of action of bioactive compound derivative from E. bulbosa as antimicrobial agent. The presence of the nitroquinone derived bioactive chemical in the E. bulbosa plant was verified by chemical analysis. However, the mechanism of action of bioactive compound against microbial cells is very scarce, and this mechanism need to be further studied. In conclusion, Eleutherine bulbosa is a hibiscus perennial flowering plant from the Iridaceae family, display antimicrobial activity against a number of the microbes. It is possible that a high concentration of the phytochemicals such as nitrogen, anthraquinone, and nitroquinone contribute to its powerful pharmacological action. Nonetheless, existing understanding of the mechanism of the action is limited, necessitating further high-quality investigation include human and animal. When compared with the other antimicrobial medication, Dayak show a synergetic impact against numerous bacteria and fungi. That's all from me. Thank you for listening.